All right, hello, welcome everybody. Thanks for coming out on this Friday morning, and thanks to Avalanche and Ava Labs for hosting this great event and summit. Today we have three wonderful speakers, and we're going to cover cross-chain, our cross-chain future. Looking at messaging and freeing liquidity between chains, we know and we've seen advancements of these chains that the future is going to have to be cross-chain. So we have Alex from deBridge, Anett from Hyperlane, and Michelle from Ava Labs. If you guys want to introduce yourselves, that'd be great.
Hello guys, my name is Alex. I'm co-founder at deBridge. We are building high-performance cross-chain infrastructure, and now we are also launching DLN, which is like high-performance cross-chain trading protocol built on top of deBridge generic messaging. So yeah, basically we are solving the interoperability challenge, and we are solving this in a non-classical way because like we are the first team in the space that is building the infrastructure based on zero TVL principles. So without like any liquidity pools, without like continuous lock liquidity, we can like process any trading volume in DLN in terms of like cross-chain value transfers, and at the same time like deliver any number of messages per second. So yeah, our focus is like high performance cross-chain interoperability.
Hi everyone, I'm Anett, and I work as DevRel at Hyperlane, and we are essentially a permissionless interoperability protocol. We are working on a bunch of fun related products related messaging and interoperability and interchain. We are currently live on 9 mainnet chains. We are also working on Cosmos integration, which will be live anytime soon. And we are also live on 9 testnet chains, and we are excited to support Avalanche as well. And I'm very happy to be here and talk a little bit about permissionless interoperability with these amazing speakers today.
Hi everyone, I'm Michelle Tian, and I am the product manager of the Bridge and Interoperability team at Ava Labs. Super thrilled to be here and to be talking about interoperability with everyone. So what is Ava Labs doing about interoperability? You've probably heard of Avalanche Warp Messaging by now. This is the native Avalanche communication messaging protocol. And it enables any two subnets to send any message from one subnet to another, including the C chain. But what you might have not heard about yet is something called Teleporter. Yes, dropping some alpha. Teleporter is a subnet EVM specific protocol that is built on top of Avalanche Warp Messaging. And it adds certain security visions and user enhancements like handling message guarantees, replay protection, message retries, and things like that. So maybe a simple analogy just to differentiate the two, because I have seen it's been a little confusing, is think about a train system, right? You have the rails of the train system. This is the foundation for the train system, just like how Avalanche Warp Messaging is a primitive, right? And then on top of that, you have the train carts. This you can think of as Teleporter, and this is responsible for delivering a message from one destination to another. And then finally, you have, what's inside of the train carts is these messages, right? It can be people, cargo, whatever you want, whatever your heart desires, and this you can think of as the arbitrary data messages. So in a nutshell, I would say this is how you can think about it. Teleporter is built on top of Avalanche Warp Messaging, and it makes it a lot easier for people to build and integrate on top. And also the last thing I will just say is that it is all open source, so anyone can build on top of it, and super excited for whatever people want to build on top.
Thank you, Michelle. Yeah, and that's super exciting to hear about Teleporter and the vision you guys are creating at Ava Labs. I want to dive right into interoperability when it comes to standardization versus customization. We see efficiencies when there is standardization, but there's also advantages to letting market forces play out and determine the customization of interoperability solutions. Do any of you guys have opinions on that topic?
Okay, yeah, I can start. So in my opinion, like standardization of like bridging interfaces is not really the biggest problem in this space, because like there are many more other problems to solve. But like in terms of decentralization, let's think like, why do we really need it? Like, why do we do we really have any sort of standardization for like AMM interfaces or for DEXs? We have like Uniswap, right? We have like Curve. And the way we interact with this like smart contracts is very different. It's just like protocols that want to be composable with Uniswap or Curve, they just develop some kind of adapters, right, on the smart contract level. And I think the same way it works with the bridging protocols, like because anyone who wants to integrate with specific interoperability infrastructure just develop the adapter. And the interesting kind of project that we worked on jointly with other bridging teams in this space is called like MMA. It's like multi-message aggregation. And we started to work on this after like Uniswap deployment proposal on BNB chain, because like we realized and like we suggested that like instead of relying on one single messaging protocol and bearing its security assumptions, we can like aggregate multiple bridges and validate that like all bridges relay the same content for the message. And like the sort of open source repository was created, and like bridging teams just developed the adapter to plug into the sort of MMA framework. So yeah, standardization is not like really big challenge, I think. And like if somebody wants to see like how they can integrate with different bridging infrastructures, they can just like check this repository of MMA to see how these adapters can be implemented. But what is really important in the cross-chain space is like security, scalability, and like capital efficiency, because like historically all the value transfer bridges have been built in synchronous way, right? Have been built as liquidity protocols where like all the transfers are channeled through the shared liquidity pools. And the problem here is that this model is not really scalable, because like there is no single infrastructure right now that could process like $100 million of trading volume per day. Just imagine if Binance or like if OneInch would integrate the cross-chain trades into their apps. They would bring like a ton of trading volume, but like the infrastructure could not just like process this volume, because liquidity pool is always the bottleneck. And moreover, the liquidity has cost, right? Like the amount of transfer performed through the classical bridges is always like limited by the amount of liquidity in the pool. That's why the model is not scalable. And moreover, it's not capital efficient, because like the liquidity incentives are distributed continuously in time to liquidity providers, and the APY is not too big right now. It's like for some bridges it's like 8%, and like people are thinking like, do we need to stake liquidity at like 7% when like US Treasuries gives us like almost 5%? Because like people don't want to bear the risk of like the bridging or cross-chain space. And yeah, and the liquidity incentives are paid continuously, but like the transfers itself are discrete, right? So there can be days where like there is no transfers, or there can be a day where like there is a bunch of transfers, like or big volume from one chain, let's say to Avalanche, and protocols cannot rebalance this liquidity efficiently. And the last thing is like security, because like even if bridge itself is like absolutely secure, then there is a huge systemic risk of ecosystem level hacks. Like if the hack happens in one of the chains, then the attacker can just like transfer liquidity to another chain and withdraw liquidity from the pool of the bridge. And that makes the overall design to be like very sort of inefficient and dangerous from the security perspective. So there should be like some kind of innovative and new approach that should work in a fully asynchronous way. So yeah, that's what like I'm thinking about general like standardization and like what problems we have in this space.
I would say from Hyperlane perspective, we've been talking about like standardization of like bridges a lot lately, and we saw, especially coming from the Ethereum ecosystem, and with my strong Ethereum background with like AIPs, there are some AIPs that are focused on the cross-chain interoperability, and there is pretty much like somebody wrote an actual AIP on how to standardize the bridge itself and how to standardize the smart contract and how bridge will work. But we are looking into the future of like how we can standardize the bridge itself. And at Hyperlane, we have a bunch of different AIPs on like how to like do messaging transfers, how to do like provide like a liquidity layer, which is sort of like a standardized way API that you can like plug into your contract. That is like a smart contract itself. And we have a bunch of different AIPs that enables us to sort of like standardize way how transfers can work, especially standards are like the AIPs, or like, you know, we have a bunch of like different AIPs that are essentially standards. And I feel like when we are talking about cross-chain transfers, then we are talking more of like APIs and less of AIPs. So that's generally my take on how we standardize cross-chain transfers.
I actually have a slightly different opinion than Alex in that, yeah, I do think security is really important. Totally agree with you there. But I do think this standardization versus customization debate is something that is actually very relevant in this space right now, because it's kind of a precursor, if you think about it, to anything else, right? Because right now we have trillions of dollars in banks and other institutions, but there's not that much adoption. Why is that, right? Well, yes, part of it is regulatory concerns, but other parts of it is the user experience. We don't have a very good user experience. Anyone who's done that much DeFi activity knows this. There's so many different wallets, so many different bridges. It's confusing. Where are your funds? It's not showing up. I have to add this token and so forth. So it's a lot. And I think that's kind of where standardization is important, because we want to have these de facto standards or canonical bridges or cross-chain, whatever, these types of different protocols that everyone can use because they have a better user experience, a better UI, plus all these, you know, security guarantees and so forth. But I would say in general, going back to that question about which one, generally I would say we should let the market determine things naturally. I am pretty much a believer in that. I think at Ava Labs, we also generally, you know, believe in building things extremely low level, so at the primitive level, so that people can build on top, and it's very easy, customizable, flexible, and so forth. But I also think that naturally, you will have some sort of merge towards, you know, 10, 20, whatever, 30 de facto standards or canonical bridges or, you know, interoperability solutions, just because people want more unified liquidity and people want, you know, to use one, something that has been battle tested and has more activity. So generally, yeah, that's how I would think about it.
Yeah, that makes a lot of sense, and I love all those answers. Alex, one of the things you hit on was inefficiencies, and when we talk about inefficiencies, we talk about liquidity fragmentation. Can you guys each talk about the solutions you're implementing to prevent this liquidity fragmentation of wrapped assets? Yeah, that would be great if you can dive in.
Yeah, absolutely. So fragmentation of liquidity is indeed a big problem, right? And within one chain, this problem is already solved because we have quite efficient aggregation mechanism. Let's say 1inch or Paraswap or Kyber, or there is a whole bunch of projects that are solving this. But on the cross-chain space, we have asynchronous environment, and there is no way to perform the trade splitting it across multiple chains. And historically, as I mentioned, all the bridges have been solving not only cross-chain trading, but also custodying of the assets. So because custodying and trading are actually two very different challenges. And I think that the challenge of custody should really be solved by canonical bridges. And that's why we need canonical bridges. Because canonical bridges can be fully trust minimized, meaning that they can validate consensus algorithmically. But the problem here is that canonical bridges can mainly interconnect only two blockchain ecosystems. Let's say Ethereum and Avalanche, or Ethereum and Arbitrum, whatever. But the canonical bridges are not scalable, right? Because the consensus validation is a very expensive operation, and that's why you get to wait for a certain period of time when you do the transfer, let's say from layer 2 to layer 1. But canonical bridges are secure, right? They're trust minimized, meaning that they can avoid any third parties or consensus participants. And that's why we need canonical bridges to solve custody problem. And that's why whenever we have any assets, or if you want to deploy any asset on another chain, you should aim to do that through canonical bridge. And interoperability solutions are, first of all, solving the challenge of message transfer, because that's the challenge where risks are born asynchronously. So if I send a message, or if I do a cross-chain trade, I bear the risk only during the very short time period when settlement happened. So the risk is born from the moment I initiate the trade until the moment the trade is settled. And like the way we solve this cross-chain trading is through like asynchronous protocol or asynchronous like high-performance trading infrastructure called DLN. And with DLN, we are not solving custody, so we don't use any wrapped assets. We are not custodying anything. So it's a protocol where you can think about it as about like cross-chain limit order protocol. So there are makers and takers. It's like liquidity network. And maker creates the limit order. I can say, look, guys, I want to sell 1,000 USDC on Ethereum for 990 USDC on Avalanche. And I already know what asset I want to receive. I know the address of the token, and I don't want to receive like wrapped asset. I just like want to receive specific token that I expect on my wallet. And then like anyone who will provide me with 990 USDC on Avalanche will unlock my 1,000 USDC on Ethereum, right? So it's like peer-to-peer settlement, and it works like asynchronously and in a very quick manner, because like classical bridges got to wait like for, let's say, 256 blocks for some chains, or like for 15 minutes, because like the risk is borne by the entire liquidity pool. So in our case, the risk is borne by taker, like the counterparty who's settling the trade, and anyone can be the taker. Takers are mainly like private market makers or like professional on-chain liquidity managers, but like any who has liquidity can start settling limit orders. So yeah, and with this design, like users never receive any wrapped assets, and users never experience slippage, because like whenever there is a liquidity pool, it assumes that like the price discovery happens on-chain, right? And users never know the exact price. The best thing they can do is to specify the slippage tolerance parameter, because like the model is synchronous, right? But with asynchronous protocols, like the user or the maker, the one who set up the quote for the trade. So there is no slippage, and there is no possibility for front running or MEV. Just like the only way to fulfill this like limit order is to provide the exact same amount of liquidity as maker requested in the limit order parameters. So yeah, and with this design, like we just assume that like all assets are custodied by someone already, mainly by canonical bridges, and users just trade natively from native asset on one chain to native asset on another. And that avoids any kind of fragmentation issues and make the liquidity to be moved very dynamically. So anyone can move, let's say, $10 million in a single transaction from one chain to another almost instantly and with zero slippage, like at the price that is specified in the limit order. So yeah, that's basically how DLN works. And yeah, after the talk, if you guys want to get some early access, I can give you the card with like access to the gated stage launch for this product, so you can try it.
That was great insight. I really like that, Alex. I feel like you gave us a very extensive answer on this question. From Hyperlane perspective, we are actually not thinking really about like scattered liquidity, as we are focusing ourselves on building the actual messaging protocol, and we are trying to like build the way how the arbitrary data are being passed between different chains. And we are talking to like a different projects and companies that are building on the top of Hyperlane that are like providing the liquidity to the protocol itself. So we are not at the stage where we are thinking about how to deal with the scatter liquidity. So I would pass this.
Yeah, so I mentioned Avalanche Warp Messaging and Teleporter, right? And these are very low level. These are primitives. And one of the first products and use cases that Ava Labs is building on top is going to be an ERC20 token bridge. And one of the key features of this bridge is that we were thinking a lot about liquidity fragmentation when we built this in mind. And you will essentially be able to send a token from any subnet to any other subnet. And from the front end perspective, it's super easy. It's just going to be a click, and voila, your tokens appear. But on the back end, it's a little bit more complicated than that, right? So let's say you have a token that is native to the C chain, and you want to send it to subnet A. Well, this token will be wrapped once, right, from C chain to subnet A. But now let's say you want to send that token from subnet A to subnet B. Well, instead of wrapping it a second time, what we'll do is the C chain will know, okay, you want to send this from subnet A to subnet B. So first, let's burn those tokens on subnet A, and then C chain will know to mint the equivalent amount on subnet B. So this is, designs that we're trying to do to make it so that there is, less liquidity fragmentation. So I would say this is one of the things that we're trying to do.
Yeah, I kind of want to double tap there, Michelle. And Anett, you probably will have some perspective on this as well. When we look at the Cosmos ecosystem, we do see this fragmentation and the opposite of increased liquidity velocity between zones using the hub and spoke model. One of the advantages of a hub and spoke model that we're seeing with subnets and IBC zones is the scalability. How are you guys thinking about helping increase that token velocity or that liquidity velocity between subnet zones? And then Anett, how are you thinking about that when you're looking to integrate Hyperlane within the IBC ecosystems?
Yeah, sure, I can go first. So I believe Cosmos has a bit of a highway model. They have these registries that say, okay, this is kind of like the right channel to use to bridge your tokens, right? And that makes it a little bit difficult because it's not point to point. You kind of have to go all over, to the right channel to make sure you're bridging the right, token from one place to another. Whereas for Avalanche warp messaging, it's much more, wherever you are, it doesn't matter. You can send this token to another subnet. It's not a highway model. It's point to point, literally anywhere. So I think that's one of the key differentiators. And another thing is the design is IBC has a bit more overhead. So the way that we designed warp messaging is that there's a lot less overhead, and P-chain is kind of our secret sauce, because every validator that's validating a subnet also has to validate the primary network. And that's kind of where you have that decentralization and permissionless design.
At Hyperlane, we are actually thinking, we actually are using highway term as well, which is funny that Avalanche is using it as well. But at Hyperlane, we call it that we are using the highway model, where we are trying to connect sort of a different islands, which we can envision as a different tokens or different projects, and we are trying to create a highway between how to connect different chains and how to connect different layers, whether that's layer 1s or layer 2s, and how to connect them together. And then from the security perspective, we are using dedicated validator sets to secure those transfers in order to make sure that whenever you are creating a different transfer, different token transfer, so every sort of a dedicated token have its own highway or different way how the transfer is secured between the different layer 1s or layer 2s.
And one more quick thing, Nick, you mentioned this, and I realized I didn't fully answer it, is different designs, right, like efficiency. So Cosmos has light clients, and we spent a lot of time thinking about the right type of signature aggregation scheme. And we are using BLS aggregated multi-signatures. And I think that's another thing that we've spent a lot of time at Ava Labs doing, is thinking about the really amazing, cryptography and technology and innovation out there, and try to incorporate that. So one of the key ways that we try to increase efficiency and keep costs down, and that's why we have lower overhead, is because of this, aggregation scheme that is very efficient, plus the P-chain, all that good stuff. But I think that's another key differentiator versus the light clients that Cosmos uses.
Yeah, I love that. And I think one thing you guys have all touched on in this conversation, and that seems very important, is security. I remember using my first bridge, and it was a very centralized bridge. Later got hacked, obviously, and we hate to see liquidity being drained from the market, especially when we're trying to grow our ecosystems. Can you guys talk about how you guys are preparing to centralize solutions and implementing them within, your bridging and interoperability solutions?
Yeah, so I think, first of all, again, it's very important to differentiate like canonical bridges to non-canonical bridges, right? Because like non-canonical or interoperability solutions inevitably have validation layer, meaning that there are some parties, like companies or like people who are validating, who are running nodes. And these parties can inevitably collude and forge the message. So that's like inevitable for the interoperability solutions. That's why absolutely all non-canonical bridges bear assumption that like validators will not collude. And validators can be represented in different forms. That can be like oracles and relayers. That can be watchdogs in case of optimistic approach, or guardians, whatever. But like at some point they can collude. That's why the goal is not like only to maximize the decentralization, but also to maximize financial guarantees. So in deBridge, we are saying like, look guys, there is no way like mathematically to build absolutely trust minimized non-canonical bridge, but there is a way to provide really good financial guarantees. And in deBridge, we have like delegated staking and slashing module that we'll launch after TG. And this is the module where anyone can delegate liquidity for validators to participate in the protocol reward distribution. And this liquidity is staked in this module, and that's not like only our own token. That's like USDC, ETH, and like liquid assets, right? And this liquidity acts as a financial insurance of validators, that they will not do anything wrong. Because like if they collude and forge the message, they just simply lose their stake and rotate it, replaced by governance by another validators. And that brings really good sort of economy, because let's say we have $50 million of the total collateral of the protocol, and you want to make a trade for $100 million, and you're afraid of decentralization and collusion of validators. Then what you will do, you'll just split your transaction simply in two parts to make sure that like each of your trades is fully insured by the total collateral of validators. And again, you need this insurance only during the very short time period when settlement happens. Because like since we don't have liquidity pools, the risk is borne by the parties that are trading at this specific moment. Like the parties that are settling the trade like during this short time period. That's why like we don't need to chase absolute sort of trust minimization, but we need to provide like the maximal financial guarantees so that anyone who uses like cross-chain infrastructure can be confident that the message transfer or the liquidity transfer is always fully insured by the collateral of validators.
Yeah, that makes a lot of sense. And I'm going to bring it all the way back around as we think about the largest liquidity opportunities that's within the traditional financial sector. When we talk about standardization, that's probably one of the biggest ways we see adoptions, in onboarding of that liquidity. Ava Labs, I know, has launched multiple subnets that are coming to mainnet. Those are seen as permission subnets. What are we doing to think about that going into the future of being able to free that liquidity and have that operate within the larger blockchain and decentralized ecosystems?
So sorry, the question is?
How are we going to address the locked liquidity within the traditional financial sector and help onboard that into the decentralized financial sector?
Gotcha. Okay. Yeah, so we actually just launched something, I don't know if you've heard of it, but it's called Spruce. This is our institutional subnet, and it's currently on testnet, but we'll be on mainnet soon. And it's with partners like T-Row, Wellington, Wisdom Tree, and a bunch more. But essentially, I think one of the biggest issues or like hurdles for why institutions have not come to this space as much is, well, one is regulatory and compliance, but two is because of interoperability, right? There's no way to get your money from C-Chain to Subnet until now with Avalanche War messaging. So I think interoperability solutions like AWM and Teleporter are going to be huge, and it's going to enable these institutions to trade real-world assets on-chain in a decentralized manner. But also, subnets are built, the whole vision of subnets is that they're super customizable, and you can do really whatever you want. So if you want it to be extremely permissioned and closed, then you can do that. So you could have, the 10 largest banks have each a subnet, and then trade with one another, kind of like Swift, but on chain. But then if you want to do something very decentralized, you can have a completely permissionless subnet with anyone being the validator and so forth. Yeah, so it's super, super flexible. And the last thing I will just say with like the KYC point is that we have integrated with this partner called Quadrata, which is a digital passport, and they essentially issue the user a non-transferable token, and that's tied to your wallet. And that is this really cool technology because they are able to provide the user a AML score, like a risk score, as well as see if they have any ties to the sanctions list, like OFAC. So I think these are some really interesting solutions that a lot of these more traditional companies are starting to explore, because going back to decentralization, right, I think we all can agree that generally the more is better, right? That is one of the ethos, right, of blockchain and why we're here. But I think it's not necessarily how much do we need, but what is actually the use case at hand, because depending on the use case, people will want different things. And some people will value stable security and liveness over pure decentralization. So I think it's really important to think about what the use case is at hand. Yeah.
I love it, and I think that's a perfect place to end. And so thank you, Michelle. Thank you, Anett. Thank you, Alex. And thank all of you guys for showing up, and hopefully you have a little better picture of where we're headed in terms of our cross-chain future.